Hi there, I'm Daniel Woody, and I'm a statistical software scientist at Berry Consultants, where I work on building software products for clinical trial statistics. I specifically support ADDPLAN, our adaptive design planner, and today I'm going to provide an overview of this product and then do a walkthrough of a common group sequential case study. To provide a rough overview of what I'm going to go over, here's the agenda. First, I'm going to cover what is ADDPLAN and what are we doing with it. Second, I'm going to go over what can it do, and specifically focus on the design, simulate, and analyze modules. Last, I'm going to do a case study, or a high-level overview of going through creating a design, simulating options, and analyzing data. So what is ADDPLAN? ADDPLAN is a software similar to FACS, used for designing and analyzing a range of clinical trials. Instead of focusing on Bayesian design, ADDPLAN covers the common frequentist designs. We won't go into much detail about it today, but there are two main versions of ADDPLAN, a classic version and a Neo version. The capabilities are largely the same, it's mostly a different interface. We'll be using Neo today. So some of you might be wondering, where do you use ADDPLAN? And so here's an overview of the common drug development lifecycle. So for phase 1, we have ADDPLAN dose finding, which includes multiple comparisons and population enrichment. And we also have phase 3 confirmatory design options, which cover base, multiple comparison, and population enrichment. So again, what can ADDPLAN do? We can do dose escalation modules, which at the moment includes 3+3, and CRM methodology is also available. In the base module, we have planning, simulation, and adaptive analysis for up to 2 treatment arms for continuous, binary, and survival endpoints. We can also do fixed trial designs. We have a multiple comparison module, which allows you to do multi-arm and multi-stage trial design. And then we have MCP mod, which is a common methodology for combining multiple comparisons and modeling for dose finding in phase 2. Lastly, we have the population enrichment module, which includes design and simulation options for doing subgroup analyses. For today, we'll be taking a look at the base module. With the base module, you can do common group sequential designs with multiple looks as well as fixed trial designs. Within the base module, you have design, simulate, and analysis options. For design, you can answer common questions like how many patients should I enroll? What is my type 1 error? What is my power? For simulation, you can take a look at what is my expected sample size given probabilities for stopping early, what effect does conditional power have on a design, and what effect do the minimum and maximum sample size have on the trial? For analysis, the big focus is having some data. So once you have some data, you might be asking, what is my p-value? Additionally, if you're doing sample size reassessment, you may be taking a look at how can I adjust my sample size for the next interim based on some power constraints. Alrighty, let's jump into the case study. So for the case study, let's consider a clinical trial in which a novel knee replacement, the treatment, is compared to an approved knee replacement, control. Patients are randomly allocated to the treatment and control groups in a sample size allocation ratio of 1, respectively. The primary endpoint is mean improvement, in which a treatment effect of 0.5 is assumed with a standard deviation of 1. The trial significance level is set at one-sided alpha equals 0.025, and power is set to 0.8. We will do 2 interims plus a final analysis, equally spaced. Early stopping at either the first or second interim for efficacy should be possible, for which the O'Brien and Fleming boundary is selected. Alrighty, now that we've got the case study set up, let's take a look at some of the questions we can answer with the design component of ADDPLAN. So using the constraints from the case study, we'll take a look at what is the sample size for a fixed design. Additionally, we'll take a look at what is the sample size for a trial with 3 looks at the data, that is 2 interims plus a final analysis. Also, what are the cutoffs for the test statistics? We won't go into it today, but there's a few other variations you can look at, where you can calculate power based on sample size, you can add and remove interims, you can choose different alpha spending functions, and you can choose a few different effect sizes. All right, I'm going to switch over to ADDPLAN now and get the case study dialed in, and we can take a look at some of these questions. So here's the launch screen for ADDPLAN. When you open up ADDPLAN, you'll want to go to this button and create a new frame. For this case study, we'll take a look at base. The kind of data we're analyzing is means, and we're doing a design. So I'll click OK. And for the computation options here on the right, I'll expand the screen so we can see it better. We have three stages. We're doing a superiority test, and our significance level is set to 0.025. Our power is set to 80%. So I'll update that there. And the computation type we're looking at is a sample size for a given power. Here's some of the group sequential design options. So for the information rate, we're going to equally space the interims across the three different stages. And for the cutoffs, we're taking a look at O'Brien and Fleming design. Additionally, you'll see here, if you want to include a step to stop for futility, you can do that. Additionally, there's more options here for setting group sequential boundaries. Lastly, for the effect size options, we'll set our sample size allocation to 1. We're going to take a look at effect sizes from 0.5 to 0.5 with a standard deviation of 1. We're doing that because in the case study, that's what we expect our alternative treatment to be. If you have more ideas about what you think your effect size could be, you can set the range here. With everything dialed in here, I'm going to hit Compute, and you'll see on the left side of the screen, our results appear. So on the left side of the screen, we have a few different tables to show us some of the answers to the questions on the previous slide. One thing to focus on right here is the boundary for rejection of the null hypothesis. So at the first interim, the boundary is 3.4711. For the second interim, it's 2.4544. And for the third, or final, analysis, it's 2.004. Additionally, we had some questions about sample size. So when running a fixed trial, you can get an idea of what that might look like, with the expected sample size being 127, or rounding up to 128. If the alternative hypothesis is true, it comes up to 109. And then right here, you can take a look at the midway point for in between the null and the alternative being 125. So going back to our questions over here, we can take a look at sample size for a fixed design, 128 or 64 for each group. If you run the trial with 3 looks at the data, it will round it up to 130 if the null is true, 109 if alternative is true, and 125 at the halfway point. Answering the question, what are the cutoff test statistics? We've got, like we saw in the table, 3.4711, 2.4544, and 2.004 for looks 1 to 3 respectively. Now let's do a simulation. With a simulation and ADDPLAN, you can run a trial, say 1,000 times. You can set up automatic decision rules based on expected virtual responses. The big thing that people explore is sample size reassessment. Using the same design constraints from earlier, let's explore a few questions. Like before, I'll do a quick run through of the questions we can answer, and then I'll show how you can find answers to this in ADDPLAN. So, questions you may want to take a look at with the simulation is the sample size for the same trial, the overall conditional power at 80%, and sample size recalculation at each interim. You may be interested in, what is the probability we end the trial at interim 1? What about interim 2? What happens if we update the conditional power for each interim? What are the new sample sizes for each interim? What about the probability of ending the trial at interim 1? What about interim 2? Alrighty, so we're back in ADDPLAN, so let's create a new frame. And instead of a design, we're going to do a simulation. So here's options on the right side of the screen to plug in the details for our simulation. So again, we have 3 stages. For treatment arms, it's actually 2. That's 1 treatment, 1 control. Significance level is set to 0.025. It's a superiority test, one-sided, unknown variance. And when we come down here to set the seed, we're going to set it to 1 so that we can replicate some of the answers we've generated before. For the group sequential design options, like before, we have the constant information rate or uniform, where it's set to a third, 2/3, and 100% by stage 3. For the cutoffs, we're going to be using O'Brien and Fleming. And again, we're not stopping for futility. For simulation parameters, the min difference, in this case, we're just going to take a look at 0 and 0.5. And for drifts, we'll set that to 2 and the standard deviation set to 1. For sample size options, you do have to provide a sample size for the first interim, but you're then given the option to do a sample size recalculation. And let me check what we decided on for the first question, but you can do the sample size recalculation with conditional power. One option is to do the next stage power, or you can do overall conditional power. Additionally, you can base that calculation on the observed effect or the assumed standardized effect. For the observed effect, we're just using the data. And we're going to do a recalculation at each of the interims. That's right, so we're doing overall conditional power here. So I'm going to run this simulation. And now we get our results on the left side. And so the first row is looking at the null scenario where the max effect is 0. And then the second row is looking at the max effect being 0.5, which is what we think our treatment is going to be. And so some of the questions we were interested in were probability of early stopping. And so we can take a look at probability of stopping at stage 1, 2, and 3. It's 0.02, 0.472, and 0.508 respectively. And then when we're looking at the average sample size, again, the second row is the alternative scenario. We have the average sample size for stage 1 being 40, which if you remember, we had to set this, we had to pre-specify the sample size for stage 1. For stage 2, it's looking like 70.306, and for stage 3, 37.368. And coming back to some of the variations on these questions, instead of looking at overall conditional power, we can instead take a look at next stage power. So I'll clear the result and then I'll run the simulation. And then we're going to take a look at the results. So next stage power set to 80. This is going to be a bit more aggressive. So for this one, again, we have that alternative scenario in the second row. And for the probability of stopping at stage 1, that's 0.023, for stage 2, 0.631, and for stage 3, 0.346. The average sample size, again, 40 for stage 1, 99.798 or 100 for stage 2, and for stage 3, 25.55. And so here's just a rehash of the answers for each of those, again, with setting the simulation seed to 1. The last component we're going to take a look at is for running analyses. So using the same setup as before for the design, now we've got data from our first interim. So we've got 40 total subjects, 20 to treatment, 20 to control. The mean improvement for control is 0.5, where the mean improvement for treatment is 1. The standard deviation for control is 0.85, and the standard deviation for the treatment group is 1.25. For the analysis walkthrough, the two questions we're going to take a look at is, 1, what should I allocate for interim 2 based on an overall power condition of 80%? Separately, if we change to make the conditional power on the next interim, how much should I allocate for interim 2? To get these started, again, we'll create a new frame. Instead of doing the simulation, we're going to do the analysis. And we have our computation options set up on the right side. So let's make sure everything is looking good. So we have 3 stages. We have 2 study arms, significance level set to 0.025, one-sided superiority test. These options all look good. For the group sequential design options, again, it's a uniform information rate or equally spaced for each stage. We're using O'Brien and Fleming to set the cutoff boundaries, and there's no stopping for futility. We do get a few additional options. The only one that's going to be driving things in the analysis is this equal variance option for pooling the variance. And lastly, we have our sample size recalculation options conditioned on power for the next stage or the overall conditional power. So first we're going to take a look at the overall conditional power. Alrighty, so now that we've got the overall conditional power set to 80%, we're going to input some of the data. So for sample size, we have 20 subjects for each control and for treatment. For mean effect, we have 0.5 and 1. And for standard deviation, we have 0.85 and 1.25. So with everything inputted for the first stage, now we can compute a few values. So what we're going to take a look at is the expected, or the sample size needed for the next interim to maintain this overall conditional power. And so what we're looking at is 23 subjects for each treatment and control. And this is constant for that third interim. And so if instead we want to take a look at conditioning this on the next stage, all we have to do is clear the results. We've inputted the data already, and we can run compute. And then we can take a look at stage 1. And now, for this, what we have is closer to 75 subjects for both treatment and control. As you can see, that's a much more aggressive constraint for the next interim. So in summary, ADDPLAN can be used to design, simulate, and analyze common frequentist trial designs. The key part of the design module is fine-tuning the balance of sample size and power to optimize a trial's design. With simulation, you can explore conditional power and sample size reassessment approaches to further tune your design. With analysis, you can calculate p-values as well as power and sample size reassessment to tune a trial that's in progress. Thanks so much for watching. I hope that was helpful.